Hello microbiologists. In this video, I'm going to be drawing a rather simplified version of the carbon cycle. So carbon is, of course, the stuff of life, the most important element for building large biological molecules. I mean, it's up there with hydrogen and oxygen and nitrogen. But there would be no life on Earth without it. And the carbon cycle is all about making things from carbon dioxide and returning them to carbon dioxide. Now, carbon dioxide, the carbon in carbon dioxide is a very electron-poor species of carbon indeed, because you've got this carbon atom that is between two oxygen atoms, and oxygen is a very electronegative element, so it's going to be pulling those electrons away from that carbon atom. So the carbon in carbon dioxide is very strongly oxidized by those oxygen atoms. Okay, so if we want to make carbon dioxide, which is considered to be an inorganic form of carbon, into organic carbon or fixed carbon, we're going to have to reduce it. So we're going to have carbon dioxide fixation, which is a reduction process for that carbon atom. And this is done through photoautotrophy, or the Calvin cycle, typically. But it can also be done using chemoautotrophy. So there's some organisms that can use, instead of using light as the energy source, they can use different chemical species as the source of energy to fix carbon. So this process, or I should say these processes, produce essentially all of the organic matter. Or biomass of primary productivity. Okay, and this can happen aerobically or anaerobically. So in the presence or in the absence of oxygen. And often we think of what we do, you and I do, through processes of respiration and also through fermentation. Well, we're closing that loop. And these processes of respiration and fermentation can also happen aerobically, or they can be anaerobic. We, as multicellular eukaryotes, perform aerobic respiration, where we convert organic matter like glucose into carbon dioxide. But we know that there are other anaerobic organisms, like yeast, for example, that are eukaryotes that can ferment glucose into carbon dioxide and other metabolites. So this process, it is oxidative because we're taking that carbon and we're returning it to a state where it's in that relationship with those two oxygen atoms, and it's that very reduced form of carbon. But there's also another path, which is redox neutral, where we're neither adding or removing electron density from the carbon atom in biomass. And that's done through this other piece of the puzzle here, which sometimes we can take carbon dioxide and convert that into CH4, which is methane. And this can be done through a process known as methanogenesis, which is obligately anaerobic, it's also a reductive process, so we're doing a reduction reaction here. Similar to what we saw up here through carbon fixation, all this time we're taking the carbon dioxide, instead of turning it into organic matter, we're turning it into methane. And I should also indicate that methanogenesis is exclusively done by archaeans. Not all archaeans, just the ones that do it are archaeans. So that can be done by adding carbon dioxide to hydrogen gas, or there's another pathway that can take organic matter like acetate, acetic acid plus hydrogen, and we can convert that into methane. That is also a way that we get methanogenesis. So that would be the redox neutral path, is to take hydrogen gas and acetate to make methane. When we add hydrogen gas to carbon dioxide, we are reducing that carbon atom. But here it's redox neutral. Okay, but then we can take that methane and through the process of methanotrophy, eating of methane, we can reoxidize, oxidation, methane back to carbon dioxide once again. And this is another pathway that can either be aerobic or anaerobic. Okay, so we're almost done here. There's just a couple more pathways we need to add in here. One is the process of fossil fuel combustion, where we take the ancient carbon dioxide fixation, ancient photosynthesis, in the form of things like coal and in petroleum, carbon that has been fixed millions of years ago, and we can release that carbon back into the atmosphere through burning, or carbon monoxide can also be oxidized to form carbon dioxide. And both of these processes are aerobic. And they're not inherently microbial, although it should be noted that fossil fuels, for the most part, are the result of ancient microbes securing that carbon, locking it up for the eons that it's been present. And us, as humans, burning it away now is a fairly modern thing, but it is not an insignificant contribution to the carbon cycle. So that, in a nutshell, is your carbon cycle. I haven't really gone into a lot of detail as far as who is doing these different reactions, but understanding how we can go from carbon dioxide through a reductive process to get biomass, and then through oxidation return to carbon dioxide, or how methane is a very important part of this process too. All right, so that's your carbon cycle in a nutshell.